Good morning. Oh wow, how's that possible? I've got 0 viewers but 1 like. Okay. Oh, looks like maybe I've got 1 viewer now. Always surprises me how YouTube's algorithms work, but here we are. And I've got 1 viewer and 2 likes. Oh my gosh. More likes than viewers. Isn't that crazy? Oh wow, 5 viewers now. Okay, so it looks like we got a lot of people streaming in. That's great. Um, I have to say, I am very impressed with the with you with this class especially. I mean, this is a very difficult time that we're going through, but the attendance here is very good. This is the best attendance in all my classes. So way to go. I really am very impressed by the number of people who are streaming in, and we're first thing in the morning too. Like we're at 9 a.m. A lot of my other classes are at 2 or 3 in the afternoon, and I still don't. I get less than half of my class. So the fact that we get the numbers that we do is very good. I'm very impressed by that. So keep it up. You guys are awesome. So we'll still wait just a minute or two for a few more people to come in to the stream, and then we'll get started. Just going to put this link on the website. There we go. Oopsies, that's not what I wanted to do. So I thought what we'd do today is just do some kind of problem solving questions. I'm gonna throw some questions at you, and I'll give you a few minutes to solve them. I think that I found some good questions that we can play with today. Yeah, I really excuse me, I really like them. Excuse me. Okay, I think that's enough to get started now. We have about 20 people. That's awesome. So yeah, let's just jump right into it. So I want to, so we've been talking a little bit about our final assessment, and we have the choice of either a project or we have a final exam. And regardless of your choice, I think I've made it fairly clear that regardless of your choice, we're still going to do a topic map. And on that topic map, it's important for us to be able to recognize the connections that all the different topics that we've made have. So I want to throw a couple questions at you that might bridge the gap between some of the different topics that we've covered throughout the year. So I'm going to ask this question. I'm going to give you 2 minutes for it, and that's kind of how I'm going to do the rest of this class. Is I'm going to just sort of throw some questions at you, give you a few minutes to try them out, and then we'll see how they go. Okay. All right. So yeah, let's just jump right into it. So let's try, I want you to calculate the area of, let's try this one, the area of this shape right here. So let's do this one here. I like this question right here. So this is a circle. You know what? I'm going to make a nice looking circle using my geometry tool. There we go. Much better. And then we have a rectangle inscribed inside the circle, like so. Okay, this looks good. Okay, so there's our little rectangle. And of course, these are all right angles, so I'm just going to mark them with the right angle symbol, just to make sure that we are aware that this is... Oh, my audio is really quiet. Okay. Is this better? Yeah, I'm pretty sure this is better. Is there... So, are you able to hear me now? Do I need to repeat myself? Let me know if I need to repeat myself. Otherwise, I'll just keep on going. So yeah, we're calculating the area of this. So this is there's a circle with a rectangle inscribed inside of it. And we want to calculate the area of the shaded region that is outside of this rectangle here, okay? Now, of course, you're probably wondering what some of the measurements are going to be, and we'll get right on that. So let's see here. This guy right here, I'm just going to zoom in, is 4x. And this side right here is 3x. Interesting. So I'm going to give you, you know what, this might be more than a 2-minute question. I'm going to give you a few minutes. Let's say 5 minutes. I'm going to give you a full 5 minutes because this is a big question. If you would like, you're welcome to either talk about it in the chat, or if you prefer, you could message one of your peers, one of your friends, to see what they think, to get maybe a bit of a head start. I mean, I'll give you a bit of a hint. There's two things you need to calculate. You need to find the area of the circle. You need to find the area of the rectangle, okay? And then you need to subtract one from the other, right? So I think that calculating the area of the rectangle won't be that bad, but it's calculating the area of the circle that you may need a little bit of, you might need to be a little clever for that. So there's certainly a trick. So remember the things that you need for the circle. Well, it's just pi r squared for the area of the circle. What's r? Right? These are questions you should be asking. So I hope I didn't spoil too much by giving you some hints. I'm gonna give you 5 minutes. Oop, that's not what I wanted. Ooh, yikes. How do I change? No, I don't want that. Okay, hold on 1 second. There we go. Okay, 5 minutes starting now. Go ahead, chat in the YouTube chat, or message your friend if you need some help. If you want a hint, say so in the chat. I'll kind of lead you in the right direction. But yeah, let's give this one a shot. Guess I should keep my eye on the YouTube chat in case you guys are talking to me. Yeah, and the answer is going to be in terms of x. And pi. Okay, so the answer is going to be in terms of x and pi, which means that your answer will have x's and pi's in them? Yeah, good question. Almost time. One more minute? Okay, sure. So, yeah, I'll give you one more minute. Yeah. One more minute it is. Looks like we got some solutions. 25x squared over 4 times pi minus 12x squared. Maybe. I don't know. We'll see. No, I mean, this is a big question, right? So you don't have to feel bad. Like if you didn't get it right away, sometimes it might just take a minute. I mean, it's the thing about problem solving is there's a lot of different things to try, right? So maybe you happen to try something that didn't work, right? And then that's a bit of time that it took, right? Where someone else may have just tried something and it happened to work, right? And then boom, you're done. Okay, so yeah, I'm gonna jump into it now. Okay, so we got the circle, we've got the rectangle. Let's talk about the circle first. So here's my circle. I want the radius of that circle, right? That's the big sort of measurement of the circle that we're looking for. Thing is, we're not told what the radius is. The radius is from the center all the way to the edge, right? So it's this length. But the nice thing about the radius is that it doesn't matter where on the circle you're talking about. So how about, why don't we try to measure a point that we know like a little bit about? Like this point right here. Like this point is the intersection of this rectangle and the circle, right? So that's kind of where my mind goes. And then I can also notice that if I were to extend it, like I could find the diameter, without too much trouble, right? There's my nice little diameter. Yeah, see the diameter? So there's my diameter. The diameter happens to also be the hypotenuse of a right angle triangle for which we know the length of both legs, right? So I think that's our ticket, is to find the diameter of the circle. Once we find the diameter of the circle, we can cut that in half. We'll find the radius. Once we have the radius, then we will use that for the formula pi r squared. Okay, so the diameter, let's calculate the diameter. That's going to be what? Pi, not pi. It's going to be, well, let me just copy out this little rectangle that right angle triangle that I drew. I've got 4x, I've got 3x. This is a right angle triangle. So the diameter is this hypotenuse. I'm just going to write d. So d is equal to the square root of 4x squared plus 3x squared. Okay, that looks good. And that's equal to, well, the square root of, well, 4x squared. Please make sure that you're not making this mistake. It's not 4 times x squared. It's the whole of, it's all of 4x squared. So that would be 16x squared plus 9x squared. Okay, and that's equal to, well, I've got 16 plus 9, which is 25, so that's 25x squared. And, well, that would be 5x. Okay, awesome. So that's what our diameter is, 5x. By the way, you may notice that we've got some nice whole numbers, 3, 4, 5. Just as a little trick, now this is a trick that maybe you already know, but if you don't know, it's a really handy trick, and it's actually a trick that is very useful in your day-to-day life. That if you have a triangle with the sides 3, 4, 5, then you have a right angle triangle. And carpenters use this all the time. It's called the 3, 4, 5 trick. If you want a right angle triangle, what you do, or sorry, if you want like two walls to be right angles to one another, what you can do is you can measure like 3 inches. Well, not 3 inches would be too small. You can measure like 3 feet or 3 meters or 3 times any unit that you want. So you just measure up 3 here. You would measure 4 here, and then what you do is you get a board which is 5 units, whichever unit you decided to use, and then you make sure that it's 5 from here to here, and then you're guaranteed to have a right angle there. That's called the 3, 4, 5 trick, and carpenters use it all the time. So what I'm trying to say is that if you know that two sides of a right angle triangle are 3 and 4, then the hypotenuse is 5. It's a very common right angle triangle. So 3, 4, 5. This is a 3, 4, 5 triangle. This happens to be 3x, 4x, and 5x, but you'll always get that 3, 4, 5 with a right angle triangle. Okay, so I know that the diameter is 5x, so that means that the radius, let me erase this, the radius must be 5 over 2x, right? Because it's going to be exactly half of the diameter. Okay, so the radius is 5 over 2x, which means that let me choose a different color here, how about yellow? The area of the circle is, well, it's pi times r squared, which is going to be pi times 5 over 2x squared, which is equal to pi times 25 over 4x squared. And let's just write this in a way that looks nice. Usually we put the coefficient in front of the variables. And even though pi is a constant, we still sort of treat it like a variable in terms of the way we write the numbers. So we'll call this 25 over 4 pi x squared. So that's the area of the circle. So that's what we're starting off with. Looks like some people are, I see some 25 squared over 4 times pi. So that's good. I think that some people are on the right track there. Now let's find the area of the rectangle. So the area, this shouldn't be too bad to calculate. Area of rectangle. Well, let's see here. The area of the rectangle is going to be 3x times 4x. So I got 3x times 4x, and that would be 12x squared. Okay. So the area of the shaded part, so the area of the shaded region is going to be, well, 12x squared. It's going to be the area of the circle, right? It's going to be the area of the circle minus the area of the rectangle, right? Because I'm going to start off with a circle. That's going to be all of this. And then I'm going to subtract the negative space, right? The empty space, okay? So let's see here. I've got 25 over 4 times pi times x squared minus 12x squared, and that in and of itself is the answer. I want to simplify this a little bit, so we can simplify this because these are like terms. These have x squared as their variable, which are like terms. So I'm going to combine these. So this is going to be, I'll throw this in brackets, 25 over 4 times pi, not x squared yet, minus 12 all times x squared. And either this or this, I would accept. The latter, this one, this is technically like the final answer. Like this is the correct answer because this is simplified, and the other one, this is not simplified. So this is the better answer, but I would accept both. Both would be perfectly valid answers as far as I'm concerned. Are there any questions about that one? Let me know if you have any questions about any of it. I'm going to find another question, kind of like it. No? Okay. Here's one. I like this question. Everyone thinks that trapezoid. I mean, if I asked you what a trapezoid is, I'm sure a lot of you'd be able to tell me. But it's kind of like the least popular shape. Oh, why do I leave a 5 over 2 as a fraction instead of just dividing it? 5 over 2. I mean, I could if you wanted. Yeah, absolutely. You could turn this into 2.5, right? And then you would have, well, 2.5 squared, what was that, 25, what's 25 squared? That would be 1/16. Let's see what 2.5 squared is. The reason why is because now I need a calculator, right? 2.5 times 2.5. Okay, I should have known that this is 6.25. So you could have done 6.25, right? So yeah, if you want to do decimals, that's fine. But the thing about decimals is I find that I have to start resorting to a calculator because, yeah, things like 2.5 squared, I mean, yeah, that is something that I should probably know off the top of my head. Hi, Goosey. Yeah, I would just leave it as a fraction. Fractions seem a little more daunting at first because there's all those rules with fractions. But the whole point of leaving things as fractions is to why is it 5 over 2 instead of just 5? I'll talk about that in a second. So yeah, the thing about fractions is that yes, there's lots of rules, and at first, when, I mean, you guys have been dealing with fractions for only a couple of years, right? Like I've been working with fractions for decades, right? So I've got a lot of experience. I feel very, very comfortable adding, subtracting, dividing, fractions, all that stuff, all the fractional rules. You know, I'm a teacher. I know the rules by heart, right? You're still learning the rules. You're still subject to making mistakes with the rules. So I think that a lot of students prefer to use decimals because There's something comforting about decimals. There's not a lot of rules when it comes to adding, subtracting, multiplying, dividing decimals. The thing is that it's challenging. Like five if I want to square, 5/2, right? If I want to square that, well, like 5 squared is super straightforward, right? But I know that it's super, like, that's an easy thing to square, right? I square the top number, I square the bottom number. Both of those are small numbers, very easy to square. 6.25, or sorry, what was it? 2.5 squared. That's pretty much, that's equivalent to squaring 25, right? Like, what's 25 squared? Like, I had to think about it. I couldn't think about it on the spot. I had to resort to my calculator. So yeah, you can use decimals. You can convert to decimals. Nothing in the question said that you had to stick with fractions. That said, I would stick to fractions because you can do this stuff in your head. The mental math is easier. Okay, and another question was, why is it 5/2 instead of just 5? Really good question. So the 5 came from this right angle triangle, right? We solve for 5 by saying that this is 5x. The hypotenuse of this right triangle is 5x. Well, where did that hypotenuse come from? Came from over here, right? This was our right angle triangle right here. Okay, so the right angle triangle, the thing that we're solving for is the hypotenuse, right? So we're solving for the hypotenuse, which is this side right here, and the hypotenuse happens to be the diameter of the circle, right? So the diameter of the circle, that's really important information, but what we're really looking for is the radius of the circle, right? We actually want the radius of the circle, and the radius is the diameter divided by 2, right? So that would be 5x, right? That's our diameter is 5x, so the radius is 5x/2, right? So or in other words, 5/2 times x. Okay, hope that makes sense. Okay, and if you have any other questions, just say so in the chat. Otherwise, I'm just going to move on to the next question. So calculate. Really good questions today. Really good questions. So we're going to calculate the area of this guy right here. And here, I'll use the geometry tool again. Trapezoids. All right. I think I was saying before, no one seems to think trapezoids are important. But a lot of tables at school are trapezoids, right? We have trapezoid tables. I'm about to ask you a trapezoid question. 6x plus 2. And then the height of the trapezoid from up and down is 4x minus 2. So I'm just curious if, let me know in the chat right now if you happen to remember, the area of a trapezoid. So let me know if you remember what the area of a trapezoid is. Okay. So I'll give you just a few seconds. You don't have to tell me what it is, but just let me know. Do you remember what the area of a trapezoid is? I wonder, because a lot of students forget this one. Doesn't seem to be a whole lot of do you find the square then triangles? Sort of, not here. I'll give you like the very quick version of square plus 2 triangles. I mean, you could do that. That would be pretty tough, though. There's a really straightforward formula to it. Okay, do you guys remember how to calculate the area of a parallelogram? You guys remember that? No? Oh boy, oh boy. Oh, base times height, almost. Yeah, you're on. Oh, okay. Base times height is the area of a parallelogram. Oops, that's not what I wanted. So yeah, we would have our height, we would have our base, and the area of a parallelogram is just base times height. You want to know why? Of course you do. Well, what would happen if we were to sort of chop this, like slice it with a knife, and then we would have this shape right here, right? And then we would have this shape right here, right? And then look at this. We just move this over here. It's a parallelogram, so those lines are actually supposed to be parallel. The base is right over here. Height, it's a rectangle. It's just a rectangle that's been rearranged, right? I say we throw pi into this formula. Yeah, let's leave pi out of this formula. I think we'd be setting ourselves up for trouble if we were to put pi into this formula. Okay, so let's see if we can remember the area of a trapezoid. Now, the area of a trapezoid, it's kind of, I really wish that there was more emphasis on this in school, because I remember when I learned the area of a trapezoid, I promptly forgot it. It wasn't until I actually like needed it for something that I started calculating it, and it's something that actually comes up in calculus quite a bit, finding the area of a trapezoid. So let's see if we can remember the area of a trapezoid. Now I'm just trying to remember how to prove that. Shoot, of course now I forget how to prove the area of a trapezoid. You know what? I'll come back to the proof in a minute. I'll do it after this. I'll just quickly. I'm gonna have to think about it. I should have prepared something ahead of time. But anyways, the area. So if we have just a general trapezoid, a trapezoid has 3 key measurements, all of which are listed in our question. We have 2 bases. Can this be done after this? Because I have a headache and a brain break. Yes, we can have a brain break in just a minute. We have 2 bases, base 1, base 2. Okay, so those are our 2 bases. And then you have the height of a trapezoid. So a trapezoid, like I said, has 3 key measurements, 2 bases and a height. And the area is base 1 plus base 2 over 2. So the way I think about it is you take the average of the bases, and then you multiply that by the height. Okay? You multiply that by the height. Oh, I remember how to prove this again. I remember now. Do you know how phones charge? Yeah. Okay. So you need to charge your brain. Well, we got 10 minutes of class. Can we push through? Can we push through? You can also press pause too, and that's another thing too. You could press pause and then go take a nap or something, have some water. Maybe it sounds like maybe you need a Tylenol, and then come back when you're ready. Okay. Don't use Android. Okay, anyway, so maybe what we'll do is I'll give you 5 minutes for this question, and then I'll solve it. So here's our golden formula. This is the formula that we need. So I'm just gonna leave that there for you. I'm gonna give you 5 minutes to solve this, starting now. Yes, this is a plus sign. Think of it like the average of the bases. You take the two averages, or the average of the two values. Your answer. Can you remind me what your question was? Just going through the chat. 6.25. The answer to this. No, don't spoil it. Don't spoil it. It's possible. It's possible. You could text another student if you want. Maybe see what they got, right? See what they did. Okay, let's try this one out. Okay, so what we're gonna do is I'm gonna solve this one, and then I'm gonna show you where this formula comes from. Okay, so we're gonna derive this formula. Okay, so let's calculate this. So I've got the sum of the two bases divided by 2 multiplied by the height. So I'm gonna add these two bases. So I've got 2x. Here, I'll use a different color. How about yellow? I've got 2x minus 3 plus 6x plus 2 all over 2. Okay, so I'm going to take that, and I'm going to multiply all of that by the height, which is 4x minus 2. 4x minus 2. Okay, so let's solve this. Okay, so I've got the like terms here are 2x and 6x. So I've got 2x and 6x. Those are the like terms. I'm going to add those together. That gives me 8x. And then I've got negative 3 plus 2, which is negative 1. So I've got 8x minus 1 over 2. I'm going to multiply this by, well, this is going to be 4x minus 2, and that's over 1, right? Anything is over 1, right? So what I'm going to do is I'm going to multiply the numerators together, and I'm going to multiply the denominators together. So this gives me, well, 8x times 8x, or 8x times 4x is 32x squared. Okay, I've got 8x times negative 2, which is negative 16x, minus 1 times positive 4x is minus 4x, and then negative 1 times negative 2 is positive 2, and that's all over 2 times 1, which is 2. Let's solve that. Let's simplify that. I've got 32x squared minus 20x plus 2, all over 2. And just to simplify it all the way, let's simplify this as much as we can. I'm going to divide everything by 2. So this is going to be equal to 16x squared minus 10x plus 1. Because all of these are even numbers. That's an even. And they're all being divided by 2. So let's just go ahead, divide everything by 2. So we get 16, 10, and 1, because those are the halves of all of these numbers respectively. So that's what we got. This one might have been a little more challenging than the others, but that's okay. Where does that formula come from? Well, here's the thing about trapezoids that may be a little confusing, is that these two lines, it doesn't have to be symmetrical. Like this is a trapezoid, right? That's a trapezoid. That still counts, okay? So let's just make our trapezoid look maybe something like a little bit more like the way we would expect. They're kind of shot out like that. So I've got base 1, oops, I want the actual pencil back. Base 1, base 2, and height. So here's how the formula works. What we do is we'll take this and we will copy it, and then I'll make another one, paste it, and then I will flip it upside down and put it over here, like so. What the heck? There we go. Okay, so now I've got 2 copies of it. Here's my two trapezoids, okay? So this is 2 trapezoids. But you'll notice now what I've done is I've kind of eliminated this portion. Like, who cares about that now? So the important thing to notice here is that this side is going to be parallel to this side, okay? So I've got, now this is a parallelogram. This is a parallelogram with, well, this side right here, this yellow side, is base 1 plus base 2, right? Base 1, and same with this side right over here. This is base 1 plus base 2. And the height is still h. So if you remember the area of the parallelogram, so I'll write area AP for area of the parallelogram. The area of the parallelogram is going to be, well, base 1 plus base 2, right? Like this side right here, this length right here, times the height, okay? But hold up, we were trying to figure out the area of the trapezoid. But to get this parallelogram, we had to double this trapezoid, right? We've got 2 of these trapezoids now. We made a copy of them. So whatever the area of this big parallelogram is, that's double the area of this single trapezoid that we were looking for. So the area of the trapezoid is equal to 1/2 of the area of the parallelogram. So in other words, the area of the trapezoid is equal to base 1 plus base 2 divided by 2 times height. Okay. I mean, if you wanted to, the whole thing could be divided by 2. But the way I like to think about it is, I mean, sort of another sort of intuitive way of thinking about it is that you're taking the average of the bases. So you can kind of imagine that if you have a trapezoid like this, if you take the average of the bases, you're kind of just doing this. You're saying, okay, well, the average of the bases is going to be like the middle of these two lines, right? Like right down the middle. That's the average of those two bases. Same with over here. Take the average, boom, 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 and then now you have a nice little rectangle that is the same area. So that's another way of thinking about it, is that you're kind of like you're removing this, but you're adding it in there, right? Those two areas would be the same, and then you're kind of adding this from this. So that's another way of thinking about it. So maybe think a little bit about trapezoids over the weekend, because they're great shapes. So I think I'll make the exit slip straightforward today. So the exit slip is, what is the area of a trapezoid? Okay, keep it simple. I don't want to overwhelm you with the exit slips. Just want to make sure that you're handing them in. Just one more thing before I go. I know I'm a little bit over time. Homework for today. Yeah, I'll put some homework up on the website today. I'll just kind of get kind of a selection of questions just to get you thinking about some of the stuff we did today. But yeah, just one thing before we go. I'll be talking a little bit more about the project next week. Yeah, just write the formula for the exit slip. That's it. So I'll talk a little bit more about the formula, about the final project next week. Basically, what I still need to do is come up with a rubric for the project. So I'll be coming up with a rubric for the project. That's something that you can use as a guide to make sure that you're going to be rewarded for the work that you do. I don't want you to put in a whole bunch of work for something and then not get rewarded for it, but I also, at the same time, I do have to have some guidelines. So basically the gist of it is that I need to make sure that you're demonstrating your learning of several topics. So yeah, I'll talk more about that in next week about the project. So if you're thinking about doing the project, stay tuned. There's more information. What I would start thinking about now is which topics in this class you would like to cover. And everybody included on this, I think now would be a great time to start coming up with a list of topics that we've covered since the beginning of the year. I forget who, but someone asked me for a list of topics, I think on Instagram, and I'm hesitant to do that because well, first of all, it's a lot of work for me, and I think it's more valuable if you do it. So you can go through your notes, go through old assignments, just start listing all of the topics that we've covered throughout the year. I think this would be a great thing to share with other people too. So if you would want to work in groups, to start coming up with a list of all the topics that we've done throughout the year, that can be really useful for your topic map, right? Because everyone here has to do a topic map. So I think that having a good list of all the topics would be very valuable. And yes, first semester stuff as well. Yeah, for the whole year, everything that we've covered throughout the whole year, I think it's a great idea to start making a list of every topic that we've done. Yeah, because second semester we actually haven't covered a whole lot of new stuff in the second semester. We did circle geometry, we did some trigonometry, we did factoring trinomials. We did a lot of stuff with factoring trinomials. We did some stuff on number systems. But I mean, the things that you did in first semester, I mean, you had exactly twice as much time in the first semester as you did in the second semester. So by that regard, you would have covered at least twice as much, especially because right now we're doing a lot of review, right? We've been reviewing topics from first semester. So there's a lot of topics in first semester. So make sure that you're going back to first semester and yeah. So yeah, if you have any questions over the weekend, don't hesitate to reach out. I'm gonna post some homework very shortly. Not too much, but just enough for you to get some practice with this stuff. Mostly just some stuff where you're calculating the area of sort of weird shapes that have, you know, the lengths and widths that aren't just a whole number, that they're actually like a rational expression. Anyway, I'm gonna sign out. I'll talk to you guys on, I guess, Monday. So Monday will be our next class. So have a good weekend. I'll talk to you then. Bye bye. No, hold on. There's not a day off on Monday or anything, is there? I think there's a day off coming up. Yeah, there we go. Thanks, Mr. Schiffman. Monday does not count as a school day. So I will not see you on Monday. I will see you on Wednesday. So it'll be an extra long weekend. So I'll make sure to leave some homework for you to keep you busy. But yeah, I will talk to you guys on Wednesday because we do not have class on Monday. Looks like, yeah, it's Victoria Day. Great. So I guess we have a nice little long weekend ahead of us. I'll see you on Wednesday. Bye-bye. Oh, wait, hold on. Yeah, it doesn't count as a school day. Pardon me. Tuesday then, because Tuesday, Mr. Schiffman is our EA. Yeah, we have an EA in this class. I guess I thought I introduced you already. So yeah, Mr. Schiffman is our EA. So we have an educational assistant in our class now. So yeah, so Mr. Schiffman and I, we've been working together to sort of discuss what's going on in the class. He's helping me mark and that kind of thing. So yeah, I will see you on Tuesday because Tuesday is actually an even day of the school day cycle. So Tuesday it is. I will talk to you guys on Tuesday. Bye bye.